Hello everyone, welcome to the OneClass channel. My name is Marlon. I'm a second year student at the University of Waterloo studying chemical physics and math. Today I'm going to be going through some high school level and college level chemistry problems. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, let's get into it. So for our first question, we would like to figure out how many valence electrons nitrogen has. So valence electrons are so first you need to define what the valence electrons are. And these are going to be the electrons that are most loosely held. The reason why we tend to care about them is because they are the ones participating in chemical reactions. So both inorganic and organic chemistry, when we're talking about any form of bonds, we're talking about the valence electrons because they're the ones participating. In order to start involving core electrons, that would require high energy because they're closer to the nucleus, therefore they're experiencing more of a pull than the valence electrons that are they're basically least attracted to the nucleus because they're the ones that are furthest out. And so because they're the most loosely held, that means that they are on the outermost shell. So depending on what level of school you're at when you're asked this question, if you're using the Bohr model, and let's say that we are talking about aluminum. Let's say we have aluminum here and we have 13 electrons. We know that the first shell can take 2. Second shell can take 8. So we reach 10 now, and that leaves 3 on this last shell. And so if you're using this model, you would say that aluminum has 3 valence electrons. If you're using the more accurate model derived from quantum mechanics, then you'd have the s orbitals, and that would be 1 orbital, so it can take 2 electrons. You'd have the p orbitals that are 3 orbitals, and hence it could take 2 by 3, so 6 electrons. And you have the d orbitals that are 5 of them, and so they can take 5 by 2, so 10 electrons. You have other orbitals, but we tend to stay between sp, df. And so for aluminum, our example before we get to this question, we'd need to write out its electronic configuration. You can use Madeline's rule or Madeline's diagram, but it's summarized quite well by the periodic table. And so if I just read the periodic table, H and He cover 1s2, lithium and beryllium cover 2s2, boron all the way to neon would become 2p6. Sodium and magnesium would be 3s2. And then lastly, to get to aluminum, I see, yes, I do enter the 3p area, but I'm only taking one step, and so it'd be 3p1. And so all of these would be forming closed shells. So the 1s2 are the 2 electrons we identified here. The 2s2 plus 2p6 add up to the 8 electrons we identified here. Then the 3 electrons on our valence shell in this older model would be the 3s2 and 3p1. So again, we would get 3 valence electrons. This is if you're using the quantum mechanical model, and this is if you're using Bohr's model. And so we are going to use the electron configuration to figure out how many valence electrons nitrogen has. Nitrogen has 7 electrons. And so when I write it out, it would be 1s2, hydrogen, helium, 2s2, lithium and beryllium. And then when I enter the 2p area over here, I say I'm only taking 3 steps. And so it's going to be 2p3. So recall, this would form the first ring with 2 electrons, and this would form the second ring, and I can see that I have 5 electrons. So my answer would be that I have 5 valence electrons. And so if I was drawing the Lewis structure, I'd only show you the valence electrons, the electrons that are participating in anything going on around nitrogen, and I'll just draw out the 5. And that's it. Another way to answer this question is the group number tells you how many valence electrons it has. Depending on whether you call this group 15 or group 5, either way it has 5 valence electrons, all of the elements that are inside of this column.